Started with the name of Almighty Allah, the most beneficent, the most merciful. Currently we were sharing about anti-neoplastic agents or anti-cancer drugs, and I did talk to you as there are 5 fingers of the hand we can intervene into this by 5 different ways. Number 1, alkylating agent. Number 2, natural products. Number 3, antibiotics. And number 4, antimetabolites. And number 5, phosphate kinase inhibitors. Now, we have discussed a lot about natural products, and we are not going to deal with alkylating agents because in the modern science the alkylating agents are deleted from here because they have got lone pair of electron on the nitrogen and they itself causes the cancer. Therefore, they have been omitted. Now, the current dilemma of the talk is anti-metabolites. Anti mean against, metabolites mean whatsoever the metabolites have been formed. Now, we are using the term anti-metabolites, and we will be able to know the pathway. How does a drug is metabolized and how does a DNA and RNA is formed, and we will be knowing, and then we will be able to understand it. These anti-metabolites are categorized into number 1, pyrimidine anti-metabolites. Pyrimidines are the smaller bases of the DNA molecule. Number 2, purine antimetabolites. These are the larger bases of the DNA molecule. And then foliate antimetabolites. These 3 are there. We will be dealing one by one class member, and we'll be discussing later on all these things. Before starting it, I would like to give you the overview of antimetabolites. How does these be able to work? It is as follows. Antimetabolites are compounds closely related in structure to a cellular precursor molecules. Yet these impostor substances are capable of preventing the proper use of formation of the normal cellular product. These antimetabolites are similar enough in structure in many cases to interact with the normal cellular process. So they make little difference would be there, and I will just explain it to you while I'll be dealing with 6 marker purine, but differ in a manner sufficient to alter the outcome of the pathway. That means it should not form that is forming. We want that it should not be formed. Therefore, the antimetabolites is entrapped somewhere in the pathway with another molecule that is normal therein. Most antimetabolites are effective cancer therapeutic agents via interaction with the biosynthesis of nucleic acid, that is DNA and RNA. Therefore, several of the useful drugs used in antimetabolite therapy are purine, those are the larger bases, that is adenine and guanine, and pyrimidine, cytosine and thymine, and then the folates and the related compounds. So there is number 1 purine, number 2 pyrimidine, and number 3 folates. And related compounds, the anti-metabolized drug may exert their effect by several individual mechanisms involving enzyme inhibition and active allosteric or related sites. Mostly enzyme inhibition. Most of these target enzymes and processes are involved in the regulatory step of cell division and cell tissue cell growth. Often the administered drug is actually a prodrug form of a antimetabolite and requires activation in vivo to yield the active inhibitor. When it goes into the body and active inhibitor is formed, the administration of many purines and pyrimidines and antimetabolite requires the formation of nucleoside and finally the corresponding nucleotide for antimetabolite activity. the anti-metabolite and its transformation product may inhibit several different enzymes involved in the tissue growth. These substances are generally cell cycle specific, as I've already talked to cell cycle, with activity in the S phase of the cell. The purine, larger bases, and pyrimidine, smaller bases, antimetabolites are often compound incorporated into the nucleic acids and the nucleic acid polymers, DNA, RNA, etc. The antifoliates are compound designed to interact at cofactor site for enzyme involved in the biosynthesis of nucleic acid bases. The biosynthesis of these nucleic acid bases depend heavily on the availability of foliate cofactor. Hence, antimetabolites of foliates find utility as anti-neoplastic agents. The anti-tumor effect of all these compounds attempting to masquerade as the natural precursor compound may occur because of the malfunctioning in the biosynthesis of the corresponding macromolecule. Classical example of pyrimidine and purine antimetabolites are 5-fluorouracil. This is pyrimidine, and 6-mercaptopurine. This is purine metabolites, antimetabolites, respectively, and the classical antifoliate is methotrexate. Now, we have to emphasize upon exemplary antimetabolites. In the case of pyrimidine, it is 5-fluorouracil. In the case of pyrimidine purine, it is 6-mercaptopurine, and as an antimetabolite, we have methotrexate. These are the effective agents which are classically used in the anti-neoplastic agents. Now, we are going to deal with one of the 6-mercaptopurine, which is purine antimetabolite drug. Purine antimetabolite drug, small, larger bases, that is adenine and guanine. In this respect, the pretty good example is of 6-mercaptopurine. Now, this is 6-mercaptopurine. This is carbon 1, 2, 3, 4, 5, 6. 6-mercapto are thio. Previously there was O, and O has been replaced only by S. So this is the only difference. For that matter, due to this difference, false perception would be there in DNA, and the DNA molecule would not be able to form. That's why this drug, 6-mercaptopurine, is very effective in treating the cancer, so that it would not be able to entrap into the DNA molecule due to change of this O by S, and DNA molecule will not be formed, and further elongation of the DNA molecule will not be occurred. There are many other drugs which are also included in the scope, and we exemplary will be dealing with 6-mercaptopurine. And in this case, I would like to explain it to you, that is, the anti-cancer drugs based on purine structure are shown in the figure 10.9. Already it is explained to you. There is the 10.9. You can see. This is exemplary drug, 6-mercaptopurine. Then this one, another one are anti-cancer drug based on purine and related compound. These are all this one. But particularly we will be dealing about 6-mercaptopurine, and I did mention to you in this structure we have changed only this. Previously there were O and we have attached S, and this would not be able to enter into the formation of biocycle which is used in the formation of the DNA molecule, and the cell division will not take place and elongation of the DNA molecule will not happen. So in that respect, I am going to explain it to you. The anti-cancer drugs based on the purine structure are shown in figure 10.9. I have already mentioned to you. The design of antimetabolites based on purine structure began with isosteric thiol sulfidyl group to be replaced the 6-hydroxyl group of hypoxanthine. So now this, in hypoxanthine molecule, there was O here, and that O has been replaced by S to replace the 6-hydroxyl group of the hypoxanthine and guanine. One of the early success was 6-mercaptopurine, represented by this, the thiol analog of hypoxanthine. This purine required bioactivation to its bionucleotide 6-kininosinate by the enzyme hypoxanthine guanine phosphoribosyl transferase. Once again, I would like to repeat it. Hypoxanthine guanine phosphoribosyl transferase enzyme. The resulting nucleotide represented 10.22. I'll be showing to you. This is here. This is 6-mercaptopurine. Hypoxanthine guanine phosphoribosyl transferase will convert into this compound, and if this enzyme will be inhibited, this will not be formed, and it will not be able to catch up by the DNA molecule due to presence of S on the place of O. So from it will not be able to enter into the DNA, and DNA will not be formed, and even the elongation of the DNA chain will not take place, and the cell division will stop, and the cancer will stop in that respect. The resulting nucleotide stream is a potent inhibitor of an early step in the basic purine biosynthesis, the conversion of 5-phosphoribosyl phosphorylate into 5-phosphoribosyl amine. The ribose diphosphate and triphosphate of the 6-mercaptopurine are active enzyme inhibitors, and the triphosphate can be incorporated into the DNA and RNA to inhibit chain elongation. However, the major anti-neoplastic action of the 6-mercaptopurine appear to be related to the inhibition of purine biosynthesis. So now you can see this will not form, and this will not be able to enter into the DNA, and the DNA elongation will not be taken place. Another route of this is by xanthine oxidase, thiourea acid is formed, and by another enzyme it is converted to sulf-methyl monophosphate compound. So this is all about purine antimetabolite. Next time we will be sharing with the other two form one by one. And thank you very much for training me in this respect. If you cannot understand anything, my son and daughter, do talk to me telephonically. I would be able to explain it to you whenever, wherever you would like. Thank you very much for listening to me. Allah Hafiz.